Look around you right now.
Mm,
I mean, just take a second. Look at the room you're sitting in, the device you're listening to this on, the light coming through the window, maybe the shadows on the wall. Reach out and touch the desk or, your leg.
yeah,
It all feels so incredibly real, doesn't it? It feels absolute, like what you are experiencing in this exact moment is the complete, unfiltered truth of the universe.
right.
But what if everything you are seeing and everything you describe with your words, and even the highest, most rigorous levels of mathematics that we use to measure the cosmos, what if none of that is actually reality?
It's a huge question.
What if all of it is just a highly filtered, really low resolution, heavily compressed file of a reality that you will never, ever fully touch?
It is a profoundly unsettling thought when you really sit with it.
Yeah.
I mean, we walk through life with this unshakable assumption that we're holding a perfect mirror up to the universe. We assume that when we open our eyes, the world just floods in exactly as it is.
Right, like we're just recording it.
Exactly. But we aren't holding up a mirror. We're holding up a very small, very smudged lens. And we are trying to guess what the entire universe looks like based on, the tiny little pinprick of light that manages to make it through the glass.
And that unsettling thought is exactly what we are unpacking today on this deep dive.
Definitely.
We are exploring a groundbreaking framework from a dense, highly academic epistemological report. The title is Information Mapping Relationship Between Reality, Human Cognition, Natural Language, and Mathematics.
It is quite a mouthful.
It really is. And our mission for this deep dive is to act as a translation engine, basically breaking down this doctoral level philosophy and mathematics into relatable, everyday aha moments for you.
Because the implications here are staggering. It fundamentally challenges how we trust our own senses.
Yeah.
It challenges how we trust the words coming out of our mouths, and perhaps most shockingly, how we trust our highest forms of logic, which is math.
So if language and math aren't reality, then what exactly are we doing when we speak or calculate? The whole paper revolves around this core overarching formula. It goes like this. Reality points to human sensory and cognitive filtering, which then points to natural language and mathematical representation.
Right, reality to filter to output. And this isn't just semantic wordplay. We're going to establish that this is a mathematical certainty.
Okay, let's unpack this. Because to understand how math and language are just compressed files, we have to start at the very beginning. Before we can even talk about numbers or words, before we even get into the abstract space of the mind, we have to look at the very first door that information walks through to get to you.
Which is your physical body.
Exactly. So let's talk about the myth of the transparent observer.
Yeah, humans have this intuitive belief that our sensory organs are perfect pass-through devices. We think our eyes are perfect windows, our ears are perfect microphones, and the physical reality out there just passes through them into our brains entirely unchanged.
Like we're just a live feed.
Right. But the foundational premise of this source material is that this is mathematically and physically false. Humans do not access complete reality. We only access reality states that are distinguishable by our specific biological senses.
Distinguishable by our senses.
Yeah.
So wait, if my physical hardware can't tell the difference between two things, then to my brain, there's absolutely no difference at all.
None. The nuance is just permanently gone. And we have to look at how a loss of information is literally hard-coded into our biology.
Okay, lay out the math for that.
So imagine the universe has two completely different, distinct physical states. We can call them R1 and R2. They are objectively different in the physical world, down to the atomic level.
So R1 does not equal R2.
Exactly. But when those two states hit human sensory organs, if the human sensory output, let's call it human function H, if the output for the first state is exactly the same as the sensory output for the second state.
So H of R1 equals H of R2.
Yes. Then, to the human observer, those two different realities are completely indistinguishable. The information loss happens at step one. We are absolutely not transparent copying machines.
It's kind of like a digital camera.
Yeah.
Right, but like a really old one.
Yeah, that's a perfect analogy.
Imagine taking a 1990s ultra-low resolution digital camera, maybe a 1 megapixel sensor, into the Louvre, and you take a picture of a magnificent, highly detailed Renaissance painting.
The Mona Lisa, let's say.
Sure, the Mona Lisa. The physical reality of that painting is a canvas with millions of microscopic brushstrokes, varying layers of oil paint, the physical weave of the canvas, the way the ambient light catches the dried oil in all these different angles. It is infinitely complex.
Right.
But your old camera just averages all those details out into a single blocky gray pixel. The camera didn't capture the brushstrokes, not because the brushstrokes weren't there, but because its sensor just isn't built to parse that level of reality.
And our biological senses operate on that exact same principle of averaging and discarding. Let's look at human color vision, which is just a prime example of this filtering.
How so?
Well, what we perceive as a specific shade of red is really just our brain's interpretation of a certain frequency of electromagnetic radiation hitting the retina.
Okay.
But you can have two completely different combinations of light wavelengths in the physical world, two totally distinct physical realities.
Right.
But they might happen to stimulate the red, green, and blue cone cells in your eye in the exact same mathematical proportion.
So the eye is sending the identical electrical signal to the brain, even though the actual light hitting it is completely different.
Yes. To the universe, those two beams of light are entirely different phenomena. To you, they are the exact same shade of red. The difference is permanently lost at the sensory gate. And there's a good evolutionary reason for this. I mean, our senses did not evolve to give us a perfect high-fidelity map of the universe. They evolved to keep us alive on the African savanna. You don't need to be able to perceive the atomic structure of a lion to know you need to run away from it.
Right. You just need a low-resolution alert system that screams, big teeth, run.
Exactly. It's an evolutionary shortcut.
So the universe is screaming two different things, and my eyes are just averaging it out and saying, nope, same thing, moving on. It's the same with audio, too, isn't it?
It absolutely is. Think about a dog whistle.
Right. If a dog whistle is blown, in physical reality, there is a massive disturbance of air molecules. High-frequency acoustic waves are bouncing all around the room. They're interacting with the furniture, vibrating the glass. That is a highly energetic physical reality state.
State raw one.
Exactly. Now compare that to a completely silent room where no whistle was blown. State R2. If you put a human in both rooms, the output from our hearing system for the dog whistle is silence. The output for the empty room is silence.
So H of R1 equals H of R2.
Right? Two radically different physical realities, identical human experience.
And that leads to a profound philosophical baseline for the rest of this deep dive. If our hardware is this limited, we have to accept that we are constantly walking around in a severely edited version of the universe. And here's the craziest part. We haven't even had a single conscious thought yet.
Oh, man.
We have only just let the light and sound hit our bodies. The senses are just the outer gate. Once that severely limited low-res data gets into our heads, the brain itself does even more filtering. It takes that trickle of data and runs it through incredibly complex cognitive machinery.
Which brings us to section 2 of this paper, what the brain actually does with this low-res data, the cognitive data processor.
Right.
So reality goes through a multi-step internal transformation before it ever becomes a word or a mathematical equation. It's not just a flash of insight.
Not at all. The cognitive transformation is not a single instantaneous flash. It is a highly structured, sequential process of whittling down information even further.
Whittling it down.
Yeah. The source text outlines 9 distinct steps of cognitive processing that occur between the moment a filtered sensory signal hits the brain and the moment we encode it into language.
9 steps just to process data that's already been heavily redacted by our eyeballs. Okay, we have to trace a piece of information through this gauntlet.
Let's go.
Say I'm looking out the window right now and I see a furry thing running across the grass. My eyes, the sensory filter, they just see a blurry brown shape. What does the brain do first?
The very first step is selection. Out of all the sensory data coming in, the feeling of the chair you're sitting in, the hum of the refrigerator in the background, the blurry brown shape outside, your brain just can't process it all simultaneously.
There's too much.
Right. So it selects a fraction of it. It discards the hum of the fridge entirely. It basically deletes it from your working reality.
Okay, so it throws away more data. What is step 2?
Second is attention. You actively focus your limited cognitive resources on that specific selected data, in this case, the moving brown shape. You dedicate processing power to it.
Makes sense.
Third is classification. You start grouping this new raw data with structural concepts you already possess in your memory. You categorize it as an animal based on its movement pattern.
So I'm forcing this raw, totally unique event into a pre-existing box in my head.
Yes, and that leads directly to the fourth step, which is abstraction. And this is perhaps the most destructive step in terms of information loss.
Destructio.
You strip away the specific, unique details of this particular furry thing. You stop processing the exact number of hairs on its tail, or the precise angle of its gait, or the specific shade of brown, and you just extract the general functional features.
Because keeping all that detail would overload the system, right?
Exactly. You just need the gist. Which brings us to the fifth step, memory compression. You can't remember every single millisecond of the visual tracking, so you compress the event into a tiny static memory footprint.
Like saving a tiny thumbnail image instead of a 4K video.
Exactly. Then step 6 is pattern induction. You deduce a rule. You say, small brown furry things that run away quickly up trees are usually squirrels.
Okay, so I've identified it.
Right, which takes us to the 7th step, symbolization. You assign an internal mental symbol, an abstract placeholder, to this entire conceptual package.
Like a file folder icon on a computer desktop. The icon isn't the files, it just represents them.
Precisely. 8th is regularization. You fit this internal symbol into the grammar and logic rules of your broader internal mental model. You give it a noun status, you know it can be a subject of a sentence.
Getting it ready to be spoken.
Yes. And finally, the 9th step is language encoding. You translate that internal regularized symbol into a physical instruction for your vocal cords, or your fingers if you're typing, to produce the English word squirrel.
Wow. By the time I actually say the word squirrel out loud, the amount of physical reality that has been left on the cutting room floor is just staggering.
It is almost entirely gone.
The brain isn't creating reality at all. It is aggressively editing it. It's taking a chaotic, infinitely complex universe and forcing it through a meat grinder of selection, abstraction, and compression.
The core realization here, mathematically, is that human cognitive structure never adds unobserved physical truth. It never injects new physical facts into the data stream.
It just deletes things.
It only dictates what differences from the sensory data are kept, what differences are completely ignored, and how the surviving data is organized. That's it.
I like to think about packing a suitcase for a really long trip. Like, reality is your entire house with all its messy, glorious complexity, every item you own.
Okay, I like where this is going.
Your sensory organs are the front door of the house. You can only take out what physically fits through the frame. You can't take the couch. But natural language, the final output, is the small carry-on suitcase you are actually taking on the plane.
Right.
Your cognitive structure is the arbitrary set of rules you use to decide what gets folded, what gets left behind, and how items are categorized. So you look at your closet and say, okay, shirts go with shirts, pants with pants, and I am ignoring the heavy winter coats because I don't think I'll need them on this trip.
Exactly.
You aren't weaving new clothes out of thin air to put in the suitcase. You are just organizing and discarding the clothes you already have to make them fit into this tiny space.
That is a brilliant analogy. And extending that suitcase analogy actually reveals why we have such vast cognitive variance between individuals.
What do you mean?
What's fascinating here is that two different people can look at the exact same physical reality, they receive the exact same filtered sensory input, but they produce entirely different linguistic or mathematical outputs.
Why, if the inputs are the same?
Because they are using different internal packing rules. Their cognitive structures, let's call them K1 and K2, dictate entirely different packing strategies.
So their brains are prioritizing different pieces of the same data stream.
Exactly. Let's say we have the same sensory input, a complex social interaction, like a lively, maybe intense debate between two colleagues at work.
Okay, state S.
Right. Person 1, using K1, might process this as a hostile power struggle. Their brain selects the volume of the voices, it abstracts the interruptions, and it encodes the final language output. He was dominating her.
Okay, so that's MASH output M1.
Yes. But person 2, using a different cognitive rule set, K2, based on their own history and biases, looks at the exact same sensory data. But their brain selects the laughter in between the shouting, it abstracts the shared eye contact, and processes the whole thing as a friendly attempt at connection.
So their output is, he was trying to relate to her.
Exactly. Output M2. The physical reality was identical. The acoustic data hitting their eardrums was identical. But because their cognitive structures dictate completely different rules for what is ignored and what is highlighted, their final realities are completely incompatible. M1 does not equal M2.
I mean, that explains practically every argument on the internet.
Pretty much.
We are literally running the same shared reality through completely different compression algorithms, getting completely different zip files out the other end, and then going to war over whose file is the real one.
Yes.
But the horrifying truth is that neither file is the real one. Because if cognition is just an editor, and a highly biased one at that, then the final published book, Our Natural Language, must be fundamentally divorced from the source material. Language is not reality.
It is not. And this represents a massive shift in how we traditionally view communication. We assume our words have a direct, magical tether to the physical objects they describe.
Like the word tree literally contains the essence of a tree.
Right, but they don't. Language, represented as L, is a representation of filtered features, entirely distant from the original state, because it has to pass through the sensory filter, let's call that H, then the cognitive filter, C, and finally the language encoding filter, E. The formula is literally L equals E of C of H of R. The word itself can never be the reality R.
Okay, but let me push back a little here. The words have to connect to reality somehow, right?
Yeah.
Otherwise, we would just be making meaningless noises at each other. We wouldn't be able to coordinate building a skyscraper or flying a plane if our words were completely untethered from physics.
They do connect, absolutely, but they connect on a sliding scale. And this is where we have to look at the mapping degree of language from the paper.
Mapping degree.
Yes. We can mathematically place any language expression on a spectrum between 0 and 1, depending on how well it maps back to the reality it is trying to describe.
Okay, 0 to 1.
And where it lands on that scale depends entirely on two variables: the target reality domain we are discussing, D, and the context of the speaker, C. The formula is M for mapping degree of language given D and C is between 0 and 1.
Okay, let's ground the sliding scale in some everyday examples because equations can get abstract fast. What does it look like when language hits a perfect one, like absolute perfect mapping?
So a perfect one-to-one mapping implies perfect fidelity, but, and this is a crucial caveat, only within strict, limited boundaries.
What kind of boundaries?
For example, if we are standing in a kitchen and I point at the counter and say, there are 3 apples on the table.
Okay.
In the strict, everyday, macro-physical context, this maps almost perfectly to the physical reality of 3 distinct objects resting on a flat surface. My language maps to the reality with a value of essentially 1.
So M equals 1. But why does it work there if we drop so much data?
Because in this specific context, we aren't worried about the atomic structure of the apples, we aren't worried about the slight variations in their skin color, or the exact weight of each one in milligrams. In the context of everyday counting, the mapping is perfect because the domain is deliberately shallow.
I see. We agreed on the rules of the game, and within those shallow rules, the words are perfect.
Exactly.
But what about when things get messy? I mean, most of our lives aren't spent counting apples on a table. What about the middle of the spectrum, where the mapping is greater than 0 but less than 1?
This is where almost all of human poetry, literature, emotion, and just everyday conversation lives. It is the realm of partial or approximate mapping. We are capturing a shadow of reality, but we are losing massive amounts of data in the process.
It's like trying to describe a sunset.
Perfect example.
If I stand on a beach, look at the horizon, and say, the sky is beautifully pink, I am absolutely mapping to reality. I'm not lying. The mapping is greater than 0.
Yes.
But it is definitely far less than 1. Because the phrase beautifully pink completely fails to capture the infinite gradients of light. It fails to capture the complex atmospheric scattering of photons through the dust in the air.
Right, the Rayleigh scattering.
Exactly. It loses the exact temperature of the breeze, the specific complex emotional resonance it's causing in my chest. The words map partially, but they're incredibly lossy.
The infinite gradient of reality is violently compressed into a single binary word: pink. The complexity is totally flattened.
So that's the middle. Now let's push it to the absolute bottom of the spectrum. What happens when the mapping degree is 0? M equals 0. This means there is absolutely no connection to the specified reality, even though the language functions perfectly well as language. Give me an example of that. How can a sentence make perfect sense to me but have 0 reality mapping?
A classic example used in the philosophy of language is the phrase, "The present king of France is bald."
Okay.
If you use that phrase today, right now, in the context of the current political reality of the world, it maps to 0 current physical objects. France is a republic. There is no king.
Right.
The language expression is perfectly grammatically correct. Your cognitive structural rules process the nouns and verbs flawlessly. You can picture a bald guy in a crown in your head, but its mapping degree to the target reality domain of 21st century France is mathematically 0.
It's a completely hollow file. It has the structure of data. It looks like information, but there is no actual physical data inside it.
Precise.
Which brings up a fascinating point about this constant compression we keep talking about. If language only partially maps to reality, If we are always dropping the infinite gradients of a sunset to fit things into our tiny cognitive suitcase, it means we are constantly losing data.
Yes, constantly.
But what does losing data actually mean in a strict mathematical sense? Is it just a little blurry, or is the data gone forever?
This is where we confront the strict, unforgiving definition of lossy in this framework. And it hinges entirely on the concept of irreversibility.
Irreversibility.
Right. Lossy doesn't just mean different or blurry. Just because a spoken word sounds different from a physical object doesn't automatically make it lossy. Lossy specifically describes a many-to-one mapping scenario where the original physical state cannot be uniquely recovered from the output.
Many-to-one mapping. So multiple different realities can result in the exact same output, which means once you have the output, you can't trace it back to the single reality that caused it.
That is the absolute rule of irreversibility here. Mathematically, it's expressed as a function f from the domain of reality to the domain of language. If you have two different reality states, R1 and R2, but your mapping function f gives you the exact same result for both, so f of R1 equals f of R2, then the bridge is burned behind you.
The bridge is burned.
There is no inverse function f inverse that can cover the whole domain and work backwards to tell you which reality you started with.
Let's use a math example to ground this because I think it makes the irreversibility terrifyingly clear.
Yeah.
Let's say physical reality is composed of two variables. We'll call them x and y. So reality is a coordinate pair, x comma y.
Okay, reality is xy.
Now, human cognition applies a very basic mathematical function to this reality to understand it. It adds them together. So our mental output, our math, is x plus y.
A simple addition.
Right. Now, let's say our final output, the only thing we have recorded in our language or our math is the number 5. We look at the number 5. Can we reverse engineer the exact reality that produced it?
No, we cannot.
Because if reality was a 1 and a 4, the math gives us 5. If reality was a 2 and a 3, the math gives us 5. If reality was a 0 and a 5, the math gives us 5. All of these completely distinct realities collapse into the exact same mathematical output.
Because multiple inputs lead to one output, we cannot uniquely recover the original state.
It's like a restaurant receipt. I love this analogy. Think about it. You get a receipt for a business dinner, and all it says at the very bottom is total, $50.
Right.
Now, that $50 is a mathematical truth. But the reality of what happened at that table is permanently lost. You have no idea if two people bought $25 steaks, or if one person bought $51 sodas, or if someone ordered a $40 bottle of wine and a $10 appetizer.
Exactly.
The total is accurate, but the specific complex reality of the meal cannot be reverse engineered from the number 50. But wait, if I take that receipt and I really analyze it, look at the tax, look at the time of day, maybe there's a clue I can use to figure it out.
No, and that is the brutal truth of irreversibility. The information is theoretically and practically gone. The total. $50 is what we call in math an equivalence class.
An equivalence class, what is that?
When we have a lossy output, we can't recover the exact original reality. We can only recover a group of possible states. That group is the equivalence class. The receipt tells you that the reality of the dinner belongs to the class of all possible combinations of menu items that add up to exactly $50.
So it gives you a suspect list.
Exactly. It gives you a suspect list. But it does not and cannot ever tell you which specific combination was actually eaten.
I love that concept. We live our lives dealing with equivalence classes, not reality. Averaging grades in school is exactly this, isn't it?
It's a perfect example.
If a student brings home a report card and their overall average is an 85%, that average is an equivalence class. We don't know the reality of their semester.
Right. Did they score exactly 85 on every single test all year, showing incredible consistency?
Or did they score 100 on half the tests and 70 on the other half, showing they are brilliant at some subjects and really struggling in others? The average is a completely lossy metric. The specific history of that student's struggles and triumphs is wiped out, replaced by a single, irreversible number.
And this irreversibility is the defining characteristic of all human knowledge systems. We are constantly navigating the world using these equivalence classes, believing we have a firm grip on reality, when in fact we only have a grip on the summaries. We are reading the abstract of a paper and convincing ourselves we conducted the entire experiment.
Okay, so we can't reverse engineer reality from math or language because they are many-to-one summaries. But let me push back on this idea that everything is just a reduction.
Go ahead.
Because earlier, when we talked about the cognitive processor, you said that cognitive structures add things. You mentioned they add categories, they add coordinates, they add grammar rules.
Yes, I did.
If our brains are constantly adding all this complex structure, doesn't that mean our brains are adding new reality? If we are putting things into the output that weren't in the raw sensory data, aren't we creating reality?
This is a critical distinction in the paper, and it gets to the very boundaries of what cognition can actually do. We have to separate form from evidence.
Form versus evidence.
Yes, cognitive structures absolutely contribute form, which means they provide rules, categories, syntax, grids. But they absolutely do not contribute reality evidence. Mathematical and linguistic outputs are a function of both sensory input and cognitive structure, but the structure cannot invent facts.
Okay, so the structure I use to organize my thoughts doesn't magically become a physical fact of the universe.
Right. We have to distinguish between adding representational structure and adding reality evidence. If your eyes couldn't distinguish between reality state 1 and reality state 2, say, they were both the same shade of red, your brain's internal rules, no matter how complex or sophisticated they are, cannot magically figure out which one it was.
Because the data isn't there.
Exactly. The brain cannot pull independent physical reality evidence out of thin air to compensate for the blind spots of the senses. It cannot magically invent data that it never received.
Think about historical map making as a metaphor for this. The physical Earth has land masses, oceans, and mountains. That is a reality evidence, right?
Right.
When human cognition looks at this, we lay down a grid. We draw the equator, we draw the prime meridian, we draw lines of latitude and longitude. These lines are cognitive structures. They are rules we added to the world to help us navigate it.
Yes.
But drawing a longitude line on a piece of paper doesn't create a new physical island in the ocean. The grid is the form. The islands are the reality evidence. Cognition adds the grid, but it cannot add the islands. We confuse the grid for the dirt.
That's a beautiful way to put it. We constantly confuse the grid for the dirt, and what you're describing applies perfectly to language as well. Consider the grammatical structures we use every day.
Like past tense. If I say, yesterday, the dog chased the cat. The grammatical rule of putting an ED on the word chase helps organize the story for you. It puts the action on a timeline, creating a mental grid.
Right. The timeline is the form.
But the grammar rule itself doesn't provide any new physical facts about what actually happened in the yard yesterday. It doesn't tell us the breed of the dog, the color of the cat, or how fast they were running. The grammar provides form, but it generates zero new reality evidence.
So if we accept that language is just a structural grid laid over filtered, lossy data, we have to pivot to the big one. We have to look at the most famous, seemingly pure system of all, mathematics.
Oh boy. This is where people will draw the line, because people will readily admit language is messy, subjective, and prone to error.
But math
Math is sacred.
Math is supposed to be the language of the universe. People treat math like it is divine, like it is woven into the very fabric of the cosmos. There is this deeply held Platonist view that mathematical truths exist independently of us, just floating out there in the ether, waiting to be discovered.
So if human cognition just filters and organizes, where does math actually come from? Is it discovered in the void, or is it just another biological byproduct?
This framework directly challenges that Platonist ideal. The foundational premise here is that mathematics does not emerge from absolute nothingness. The empty set does not point to math.
Right.
Instead, math relies entirely on human physical existence, our evolutionary history of sensory interaction with reality, and our specific methods of cognitive abstraction. Math is, in its genesis, deeply biological.
Math is a biological byproduct. That is a massive pill to swallow for a lot of people.
Yeah.
How does it trace back to the body?
It traces back through that exact same pipeline we've been discussing all along. Reality goes to sensory data, which goes to cognitive processing, which eventually crystallizes into formal mathematics.
From rocks to equations.
Exactly. Early humans saw distinct physical objects, apples, rocks, trees, and abstracted the idea of 1 and 2. They created symbols, which in the formal system are called sigma. They established axioms, A, they defined rules, R, and they built a system of derivations. It is a closed game board with its own pieces and rules built by human minds to process human sensory data.
But wait, if math is just a biological tool we invented based on looking at rocks, how does it describe things we can't see? Like quantum fields or multidimensional black holes? That seems like a paradox.
This is where we have to contrast what we call causal origin with current reference.
Causal origin versus current reference. Break that down.
The causal origin of math is absolutely rooted in reality. It comes from us counting things. The origin mapping is one. However, once that formal game board of math is constructed, it has the unique ability to sever its tie to current reality.
Meaning what?
Math comes from reality, but a specific, highly complex equation doesn't have to map to anything physically real right now. Its current reference can be zero.
So math can run completely disconnected from the physical world. It can just run in a void.
Absolutely. Mathematics can operate entirely in what we call non-mapping zones. Think of imaginary numbers or multidimensional geometry that goes far beyond our three spatial dimensions. These concepts operate perfectly within the rules of the math game board.
Right.
You can do calculus with them, you can write pages of proofs, even if there is absolutely no physical reality for them to map onto. You can play chess in the dark.
But if we're playing chess in the dark, and we invent an equation that happens to perfectly describe a black hole before we ever even observe one through a telescope, doesn't that prove math is a universal truth?
It proves that our internal logical frameworks are incredibly robust. But it does not bypass the fundamental limit of our biology, and this is a massive limitation that we must stress.
Okay, what is the limit?
Mathematical internal operations cannot recover the reality differences that were lost in the initial sensory phase.
Meaning what, exactly? If I do enough math, I can't figure out what the universe actually looks like.
If your biological eyes couldn't tell the difference between reality state 1 and reality state 2, if they both looked like the same shade of red to you, no amount of complex calculus, no matter how many supercomputers you use, can magically tell you if the original reality was state 1 or state 2.
Because the data was dropped to the door.
Exactly. Calculating faster or deeper inside the math game board doesn't bring back the lost physical data from the initial sensory bottleneck. The internal math engine is astonishingly powerful, but it cannot reverse engineer physical data it never received. You cannot math your way out of biological blindness.
Okay, this raises a huge, unavoidable paradox. Let's really look at the implications of everything we've established so far.
Okay.
If everything is irreversible, if our senses are lossy, if language is a low-res compression, and if even our highest mathematics can't reverse engineer reality, how on earth do human beings manage to do anything?
It's a fair question.
How do we build suspension bridges that don't immediately collapse under their own weight? How do we calculate orbital mechanics and fly rockets to the moon with pinpoint accuracy? If everything we know is just a blurry equivalence class, a rough estimate of the truth, is all hope of actually understanding reality lost?
That is the ultimate existential crisis of epistemology. If we are this blind, how do we survive? And thankfully, there's a concept in the paper that saves science from completely collapsing into nihilism. We can call it the savior clause. Local perfection in a lossy universe.
Local perfection. Okay, explain how we can be perfectly right while being fundamentally blind. I need some good news here.
The core concept that saves engineering and physics is this. While the full, total reality of an object is irreversible and permanently lost, specific, local attributes of that reality can be perfectly recovered and perfectly mapped.
So we can't know the whole truth, but we can know a sliver of the truth with 100% certainty.
Let's use the mathematical concept of uncertainty from the text, H. The uncertainty of knowing the full, infinite reality of an object based on our mathematical model is always greater than 0. H of r given m is greater than 0. The full reality is lost.
Got it.
However, this does not imply that the uncertainty of a specific target attribute, let's call it y, is greater than 0. The uncertainty of a specific isolated variable can actually equal 0. H of y given m equals 0.
Let's go back to our simple equation, x plus y equals 5. We proved earlier that the full reality, the specific coordinate pair of x, y, is permanently lost. We don't know if the reality was a 1 and a 4 or a 2 and a 3.
Right, that is the lossy full reality.
But if our only goal, our specific target attribute, is simply to know the total sum, then that specific attribute is completely and perfectly preserved. We know with absolutely 100% certainty that the sum is 5. We long the components, but we perfectly preserve the target.
Exactly.
Oh, that makes so much sense. It's like taking a black and white photocopy of a vibrant, colorful, legally binding contract.
I like that.
The original contract is printed on bright pink paper, and it has these complex blue ink signatures. When you run it through a standard black and white office copier, you have permanently lost the colors. The full physical reality of the document is unrecoverable from the copy.
Right, you can't tell it was pink.
But if your only goal, your specific target attribute, is to read the text of the contract to see what the terms are, the mapping is 100% perfect. You don't need the pink paper and the blue ink to know what the words say. You sacrifice the fill reality to get perfect fidelity on the one thing you actually cared about.
And if we connect this to the bigger picture, that black and white photocopy is exactly how scientific modeling works. It is why science is so phenomenally successful despite our severe sensory limitations.
How so?
A physicist studying a falling apple to calculate gravity doesn't need to mathematically map the apple's smell. They don't need to map its exact shade of red or the number of seeds inside it or the cellular structure of its skin.
Right, those variables don't affect gravity.
Exactly. The full reality of the apple is completely discarded by the equation. The physicist only needs to perfectly map the specific attributes relevant to the math: mass, velocity, gravity. The savior clause means we don't need all of reality to do physics. We just need our math to perfectly map the specific isolated equivalence classes we are actually measuring.
That is incredibly empowering. We are fundamentally blind to the vast majority of the universe, but we've built these incredibly precise walking sticks, math and science, that perfectly map the ground right in front of our feet, exactly where we need to step. We don't need to see the whole mountain to know where to put our boots.
Precisely.
Now, speaking of the tools we use to navigate, let's shift our focus back to natural language. We talked extensively about how language maps to reality and how it drops data, but we haven't talked about how it's actually built internally. How do we construct this lossy tool, and how does its very architecture bias our thinking?
To understand the mechanics of language, we have to move beyond just mapping and look at its internal traits. Language is not just a random bucket of isolated symbols thrown together. It has three distinct active architectural traits according to the paper. It is constructive, connective, and directive.
Constructive, connective, directive. Let's break those down. What makes language constructive?
The constructive nature means language builds up from smaller, inherently meaningless physical pieces. A unit of language, let's call it U, is composed of physical forms, sounds from vocal cords, or geometric shapes on a page.
Okay, shapes like letters.
Right. Think about drawing a straight vertical line and then drawing a curved loop attached to the top of it. In physical reality, a line and a loop don't mean anything. They are just geometric shapes.
Sure.
But when you compose them together in a specific way, you construct a unit, the letter P, that our cognitive structure recognizes. It requires physical graphics, which are subjected to character recognition, which follow combination rules, which finally results in semantic interpretation.
So we build the Lego blocks out of basically meaningless plastic. What's the connective trait?
Once you have those constructed units, you move to the connective phase. Small units form words, words connect to form sentences, sentences form paragraphs, all based on internalized cognitive rules. The small pieces connect to become a larger, cohesive structure.
And the third trait, directive. This sounds like the mapping we talked about earlier.
It is deeply related to mapping. Directive means the symbols we constructed and connected actively point to things in reality, objects, relations, or abstract states. But what's fascinating is how this pointing actually works in practice. It is not a rigid laser pointer. It is a probability cloud.
A probability cloud, what do you mean?
The meaning of a word is actually a probability distribution based entirely on context. In the math, there's a weighting formula, W of R given L and C. The weight of reality given the language and context.
So the word doesn't have a fixed meaning. It just has a likelihood of meaning something based on the environment.
Precisely. If you change the context, the weight of the meaning shifts entirely. Take the word bank.
Okay, if I say bank in the context of a conversation about a river, the probability weight points heavily to muddy shore. If I say bank in the context of Wall Street, the probability weight points heavily to financial institution. The physical symbol, the sound, is exactly the same, but the directive weight shifts dynamically based on the cognitive environment.
Okay, here's a pushback on the structure of language that I think is super relevant right now, especially with the explosion of AI.
Okay, let's hear it.
When we read or when we speak, we process language one word at a time in a sequence. Subject, verb, object.
Right.
Because human output is sequential, does that mean language itself, the actual dump structure of it, is just a linear chain of beads on a string?
This is a highly debated topic, and this framework forcefully argues against the linear assumption.
Yes. While human physical representation of language writing sequentially on a page or speaking sequentially through vocal cords in time is absolutely linear, the internal cognitive coding of that language is not. The internal structure holds long-distance relationships, nested graphs, and complex conditional dependencies.
So the mental map is like a 3D web, but we have to squeeze it through a 2D straw to get it out of our mouth.
Yes, and this offers a direct critique of a modern assumption often applied to large language models, or LLMs.
How does it apply to AI?
There is a persistent idea out there that because an AI model is trained on next unit prediction, literally just guessing the next sequential word in a chain based on probability, it is fundamentally incapable of learning deep, structural, nonlinear grammar or logic.
Right. People say it's just a stochastic parrot.
Exactly. But this framework suggests that discrete sequence slicing merely imposes a representation bias on the data. It is simply the format we use to feed the data in and get the data out. But it is not a fundamental limit on the language essence itself.
So the sequence is just the delivery mechanism.
Right. A sequential output mechanism does not prove a purely sequential internal understanding. The complex, nested 3D graphs of meaning can still be mathematically encoded within the probabilities of a linear sequence.
That is a huge point for the AI philosophers out there. Just because the robot talks one word at a time, just like we do, doesn't mean it's not holding a vastly complex, multi-dimensional map of concepts in its neural net.
Exactly.
All right, we are in the home stretch here. We have covered the biological limitations of our senses, the aggressive editing bay of our cognition, the void where mathematics plays, the savior clause of local perfection in science, and the probability clouds of our words. It is time to bring all these puzzle pieces together into the grand unified model.
This is where we synthesize the entire journey of information from the universe to our minds and back again. We can break the full life cycle of information into two distinct directions: the generating direction and the referring direction.
The generating direction and the referring direction. Let's trace the generating direction first. This is how a thought is born, right? The flow from the outside in.
Correct. The generating direction is the forward momentum of reality into our minds. Original reality at a specific point in time, RT, is filtered by human senses to become sensory data, ST. That sensory data is filtered by cognition to become a cognitive state, CT.
And then the output.
Right, and that cognitive state is encoded into natural language, LT. Simultaneously, that cognitive state can be rule processed into mathematics. So reality generates human experience, which generates language and math. The physical universe is the raw material that builds our words and numbers.
Okay, the reality creates the math. Now, what is the referring direction?
The referring direction is when we try to look backward. It's when we use our created language and our invented math to try and point back at reality, to reconstruct the universe in our minds.
But based on everything we've learned today, when we point back, we aren't pointing at the original reality. We're pointing at what we call far hat, the estimate.
Exactly. The reconstructed reality, our hat, is emphatically not the original reality, R. It is simply the reality narrowed down to that equivalence class we talked about with the restaurant receipt. We can generate math from reality, but when we refer back, we only hit the summary.
The lossy summary.
Right. Furthermore, there's a strict arrow of time here. While human math and language can be used to create new future reality, say, by humans using an equation to build a new laser or construct a new building, creating RT plus 1, our math cannot retroactively decode the past original reality that inspired the math in the first place, RT.
It's a one-way street.
Oh,
We can use our lossy tools to build the future, but we can never use them to completely unblur the past.
that's a perfect summary.
To lock all this in, let's look at the ultimate takeaways, the core propositions that define this entire philosophy of knowledge. We've spent this whole time dismantling our grip on reality, so let's summarize the rules of the game we are actually playing.
The fundamental reality we have to accept here, Proposition 1, is that natural language and mathematics are not reality itself. They are simply representations that exist only after heavy human processing. The map is not the territory. The menu is not the meal.
And the reason the map isn't the territory is because human senses only acquire the parts of reality they are biologically equipped to distinguish. If you don't have the hardware to see ultraviolet light, ultraviolet reality functionally doesn't exist in your initial data set. We're just skimming off the top of the universe.
From there, our cognitive structure dictates how we filter and encode that skimmed data. But it doesn't invent unobserved reality evidence out of thin air. Your brain is a highly opinionated editor stripping away detail and imposing a grid, but it's not a fiction writer inventing physical facts that weren't there.
And because we drop so much detail, we are bound by the irreversibility rule. If different reality states produce the same language or math output, the mapping is irreversible. The receipt just says $50. You can never prove mathematically what was actually eaten, the bridge is burned.
Which means mathematics doesn't come from a magical, divine void. It relies entirely on the human biological system interacting with reality. No humans, no human math. But just because math originates from reality doesn't mean every complex equation currently describes reality. It has a causal origin in counting rocks, but it can evolve to lack a current reference. Math can run entirely inside its own rule system without touching reality at all.
But even when math is playing chess in the dark, doing incredible things, those internal math operations cannot recover the reality differences that were lost back at the biological sensory bottleneck. You can't math your way out of biological blindness. You cannot universally reverse engineer the exact original reality from math. You can only narrow the suspect list down to the equivalence classes.
But the saving grace, the reason we aren't paralyzed by this blindness, is that while language and math are lossy for the complete reality, they can achieve perfect precision for specific, isolated target attributes. This is why science works. We ignore the color of the apple to perfectly calculate its fall. The ultimate conclusion of this entire framework is this. Language and math are the results of finite biological observers selectively retaining, structurally compressing, and regularly expressing reality. They map parts of it. They are incredibly useful tools for survival and engineering, but they are not the universe, and they can never fully recover the complete reality that birthed them.
Wow. We're just walking, talking filters. Everything we say, everything we read, every calculation we make, every memory we hold dear is a highly compressed, lossy zip file of a much grander reality that we are simply physically barred from ever truly touching.
It's true.
It is profoundly humbling. It's awe-inspiring, really, that we've managed to build civilization, split the atom, and touch the stars on such a blurry foundation. But I want to leave you, the listener, with one final, mind-expanding thought to mull over. Something that builds directly on the realization that our knowledge is just biology in disguise.
Oh, I'm ready.
If human mathematics and natural language are purely the result of our specific biological sensory limits and our specific cognitive compression algorithms, what would an alien civilization's math and language look like?
That is fascinating.
If they evolve in an entirely different environment,
Yeah.
if they saw it in completely different wavelengths like X-rays, or if their biology processed memory without a linear sense of time, or if they didn't rely on sight at all but mapped the universe through gravitational waves, would their universal truths and their grand equations look completely unrecognizable to us?
They absolutely would. Their sensory filters would produce a totally different game board.
So if they handed us their physics textbook, would it look like total nonsense? And if our math and their math both successfully built spaceships but looked entirely different, whose math would be the real one?
That is the ultimate question, isn't it?
Thank you so much for joining us on this deep dive into the limits of human knowledge. It has been a wild trip. Until next time, keep questioning the filter.